Hello everyone, welcome to the presentation of Team 1072's model for the SCUDEM 2023 competition. The team consists of me, Nguyen, my teammates Nguyễn Thanh Lộc and Nguyễn Nam Hưng, and our coach is Vũ Đỗ Huy Cường. We are from University of Science located in Ho Chi Minh City, Vietnam. Today we are going to talk about our approach to problem A of the challenge, kangaroo care. Let's quickly introduce you all to the problem. First thing first, what is kangaroo mother care? Kangaroo mother care is a method of care of human preterm infants. It involves infant being carried by the mother with skin-to-skin contact and exclusive breastfeeding. There are numerous papers explaining how kangaroo mother care can affect positively on an infant's health in various ways. As we just said, infants who are held skin to skin with their mother are more likely to be breastfed on demand. This means that their milk intake rates are improved significantly, since mother milk is their primary source of nutrition. This can lead to better weight gain in infants. So the goal of our model are to demonstrate these relationships. In particular, for a given number of hours of kangaroo mother care per day, we will determine the weight gain rate of an infant, which is measured by grams per day, and compare our calculation with the data set that we found. Also, from now on, for simplicity, we will say KMC instead of kangaroo mother care. Now we come to the main part in which we build our models. We already restricted ourselves to only one aspect of this complex problem. To simplify the problem further, we're going to make some assumptions. And these assumptions are, first, only the duration of KMC, which is measured by hours per day matters. This means that other factors, such as how KMC is employed, when is it being used in a day, are not relevant. Second, the weight of an infant at birth is 1.8 kilograms, and we only observe an infant until it reaches 2.5 kilograms. It's simply because this is a close approximation to the data we found. Finally, for simplicity, for now we assume that an infant has an infinite supply of milk. This means that KMC does not affect the milk supply of an infant. This is obviously unrealistic, but later in a more complicated model, we will drop this assumption.
Now we introduce our first model. The model consists of KMC delta, an indicator of when KMC is being used, W, which is the weight of an infant at time t, and lastly, the milk intake rate, beta, at time t. We want to see what these functions look like. First, the KMC function is defined as follows. KMC is 0 if it is being used at the time and equal to 1 otherwise. For simplicity, we assume that every day KMC is used for delta hours right in the middle of the day. Here is the illustration of the function KMC at delta equal to 6. Next is the weight function. Since KMC allows newborns to have more chance to consume mother's milk, we establish the formula. Here, gamma 0 stands for the rate without KMC, while gamma is the increment in rate with KMC. About the weight gain, it comes from two sources, KMC by a strictly increasing positive function f and other factors represented by a positive constant c. We can choose f to be a logistic function, which represents the possibility of reaching biological limit. We come up with the following system of differential equations. For parameters, we choose as follows. The first three parameters are chosen based on the data we found. Here is the result. This graph shows the dependence of weight gain per day on the number of KMC hours per day. The red line is from the empirical data, and the blue line is our calculated result from this model. As you can see, this model suggests that the longer KMC time is applied, the more weight is gained per day. Our result is consistent with the increasing trend of data when delta is greater than 10, but it is much different from data when delta is less than 10.
Now, we turn to section 3. Regarding the first model, it is obvious that we fail to notice the limitation of milk supply. In fact, reduction in mother's milk is mainly caused by stress or fatigue. If KMC occurs too long, there might be stress, which reduces the breast milk production and affects weight gain. Thus, we keep all of our assumptions earlier, but the infinity of milk supply. we also make new, less restrictive ones. Firstly, the longer the KMC process is, the more tired the model becomes. Basically, we say that KMC takes a significant amount of energy to do, and this causes a reduction in milk supply from the model. Secondly, we can effectively store pressed milk, meaning all the milk produced will not be wasted. As a result, we introduce a new model with two more components added, including the lactation rate of the model denoted by alpha T and the amount of milk available denoted by MT. Also, we come up with a small change in beta T. We assume that the milk production rate is linearly decreasing during KMC and linearly increasing while KMC is not used. To guarantee that alpha T is not negative and bounded above, we have the following formula. Here is the graph of alpha T. The following diagram shows briefly the relationship between all the components in our new model. From this diagram, we come up with a system consisting of four equations. The parameters L, gamma 0, gamma are chosen as in the first model, and we choose A equals B equals 1, C equals 5, and R equals 7. Here is the result. Now, consider the graph of dependence of weight gain per day on delta from this model. The quantity weight per day increases slightly at first, then it has a significant drop when delta goes from 10 to 14. After that, it maintains at a stable level. One reason of the drop is that prolonged KMC time causing exhaustion for the mother and greatly affecting lactation. Compared to the data, we can also see that weight per day also decreases, but much slower when delta goes from 10 to 14. One possible reason is that the data is taken from a controlled environment, so the effect of exhaustion is being limited. We can also see that the highest weight gain per day is obtained at delta equals 7.
So after two models, what can we conclude? Well, we can conclude that the longer the KMC duration, the better it is for weight gain. It is best at around 7 hours per day. This is not far off from the recommended duration of 8 hours. However, our model suggests that this is true only up to 13 hours a day. After that, it is no longer beneficial because the pressure on the mother is simply too big without outside help. But this also indicates that with competent outside help, this drawback can be negligible, as we can see from the data, therefore turning KMC into a powerful way to take care of an infant. And there are some obvious limitations to our model, namely, first, the effectiveness of KMC may not depend only on duration like we assume. When and how we use it could play an important role too. Second, the relation between weight gain rate and milk intake rate may be more complicated than the logistic function. It could also be too random and arbitrary to consider. Third, we couldn't find many empirical data to support our models. In particular, we only found one paper with data that bear a resemblance to our result. Finally, weight is not the only thing to look at when determining how healthy an infant is. There are other metrics worth considering, such as the length, head circumference, which we did not do. However, our existing model is not without strength. One big upside is that we have used step function to indicate when KMC is employed. This is highly flexible. For example, we can examine what would happen if we allow skipping KMC once in a few days. Obtaining the exact formula for KMC is theoretically possible in this case, but it's very challenging, and we could not do this part in our model due to its complexity. Most of our parameters are realistic, and we do not change parameters from old model to the new one. That is to say that our extension from a simple model to a complicated one has continuity in a certain sense. And that is the end of our presentation. Thank you everyone for listening and paying attention to us.